Welcome, my friends! A relation is a set of ordered pairs where each pair has a first component and a second component. The set including all first components in a relation is called the domain. The set including all second components in a relation is called the range. For example, consider the following relation: 2, 7, 4, 2, 6, 9, and -3, 2. The domain of this relation includes the values 2, 4, 6, and -3. The range of this relation includes the values 7, 2, and 9. Notice 2 is listed twice in our relation, but there's no reason to list 2 twice in the range, as it would be repetitive. Here is another relation: A4, B8, C9, and C11. The domain of this relation includes A, B, and C. The range of this relation includes 4, 8, 9, and 11. A function is a relation where each input or first component determines exactly one output or second component. Our first example is a function. Each input only occurs once, so there is no issue. The output of 2 occurs twice, which is not a problem. If each input occurs only once, you will always have a function. Our second example is not a function. The input C occurs twice, which by itself does not necessarily make relation number 2 not a function. The problem is that one time when C is inputted, 9 is outputted, and another time when C is inputted, 11 is outputted. The input of C is not producing the same output each time, meaning each input is not determining exactly one output. The input of C is determining 2 outputs. Therefore, relation number 2 is not a function. Consider this example. The domain includes J, Y, and A, and the range includes 3, -5, 4, -1, and -8. This is not a function, as the inputs J and A each have 2 different outputs. Each input does not have one output, so the relation is not a function. How about this example? The domain includes 1, 2, 3, and 4, and the range is k all 4 times. This is a function, as each input yields only one output. It doesn't matter that the output is repeated. All that matters is that we don't have any repeated inputs that produce different outputs. Let's look at a story problem involving domain and range. Ellison Enterprises produces tables. Let C represent the total cost of producing tables in dollars. Let T represent the total number of tables produced. In their first year of operation, Ellison Enterprises has the capacity to produce up to 100 tables. Suppose that C equals 20T plus 800 represents C as a function of T for the first year of operation. Notice that we have 2 variables. C represents the total cost of making tables in dollars, and T represents the number of tables produced. Which variable represents the domain and which represents the range? Well, since the cost is determined by the number of tables that are produced, we would think of the tables as the input, meaning our domain should be the number of tables produced, and the total cost of producing tables in dollars should be our output, or range. Can you determine the specific values allowed for the domain and range? Well, the domain refers to the number of tables that can be produced, and the problem says Ellison Enterprises has the capacity to produce up to 100 tables in a year. Anywhere from 0 to 100 tables could be produced, but we can't produce a partial table, like 1.5 or 3.7, so our domain is the whole numbers from 0 to 100, which we can write as 0, 1, 2, 3, 100. The range is the total cost of producing tables in dollars. The smallest possible cost would be when 0 tables are produced. Then our T term in the function would disappear, and the total cost would be $800. The maximum cost would be if 100 tables were produced, in which case we would have 20 times 100 plus 800, which is equal to 2,000 plus 800, or $2,800. For each additional table produced, the cost increases by $20. So the range can be written as 800, 820, 840, $2,800. Okay, the last thing we need to discuss is how to determine if we have a function based on a graph. When thinking about a graph, we consider the x values to be the inputs or domain, and the y values to be the output or range. Consider this graph. For each x value, there is only one value for y. For example, when x equals 0, there is only one value for y on the line, which is positive 1. Since each x input has only one y output, we know that this is a function. An easy way to tell if a graph is a function is to use what is called the vertical line test. The vertical line test says that a set of points on a plane represents a function if and only if no vertical line intersects more than one point. In this case, everywhere you draw a vertical line through the graph, you will only intersect the red line at most one time. And therefore, we say that this graph has passed the vertical line test, meaning that it is a function. Consider the graph of a circle. For each x value, there are multiple values for y. There are many vertical lines that can be drawn that will intersect the circle at 2 points. For this reason, we say that the circle has failed the vertical line test and is therefore not a function. There are x inputs that result in 2 y outputs. Think about this graph, which is just a set of scattered points. Is there anywhere on this graph that you can draw a vertical line and have it intersect 2 points? Yes, if we draw a vertical line at x equals 1, we notice that it intersects 2 points, meaning this is not a function. Alright, my friends, that completes our discussion covering domain, range, and functions.